A toy train moves slowly along a straight track according to the displacement s against time t graph in the figure below. Okay, so this is a what graph? This is a displacement time graph. Okay, pay attention. This is a displacement time graph. Now, explain qualitatively. What is mean by qualitative? Qualitative, it means okay. The quali means in words. Okay, you need to describe in words. There is another terms called quantitative. If describe quantitative, quantitative means in you need to calculate, you need to prove in numbers. Okay, prove in numbers. But this is a qualitative. Qualitative means in words. Explain in words. The motion of the toy train. So we look at this displacement time graph. So what do you think is how the toy train moves? So we can see here the graph is all above the time axis. Above the time axis, that means all displacement is positive. Okay, all these are positive displacement, and the zero is here. Here is the zero. Okay, displacement 0. 0 means this is the origin. Okay, this line along here, this is the origin. Okay, this line here is the origin. So as the graph moves up, that means he's moving away and away from the origin, further and further away from origin. So positive means it is moving to the right hand side of the origin. So what I can say is like this. Imagine like this. Let's talk about question A. Okay, let's say I give a number line. Just a number, a number line. Okay, just a line. Let me draw it out. Okay, this is the number line. Okay, then okay, this is the 0 meter origin. Okay, this is the origin. So here you get a positive displacement. That means all of them, you move up to 10 meter. You move up to 10 meter. That means the car, is it a toy train or a train? Train originally is over here. Okay, it start from the origin. It start from the origin. So at 0 second, it start from origin, and then it move up to 10 meter. It move to the right. Displacement is because all of these are positive value. You see, positive up to positive 10. So it move up to here, which is positive 10 meter. Okay, so to the right, it moved to the right at the right hand side of the origin. It moved up to 10 meter here. Okay, this I roughly said. Now let's talk about stage by stage, because here you see there are 3 stages. We can put this into 3 stages. 1, 2, 3. Okay, now I need to explain qualitatively the motion of the toy train in each of these stages. That means these 3 stages I need to describe. So what I can see from here, what is it mean by the gradient of the graph? The displacement time graph. What is it mean by the gradient? Still remember the gradient of displacement time graph? Yes, it is velocity. Velocity is ds over dt. Velocity is the gradient of displacement time graph. So the gradient of this graph is actually velocity. So still remember my notes here? See that? For displacement time graph, okay, for displacement time graph, the gradient of the displacement time graph is velocity. So v is ds over dt. Okay, so back to our questions. So the gradient of the graph is of displacement time graph is velocity. So what can you say about the velocity at first part? The velocity, you get a positive gradient. This is a positive gradient. It is a positive gradient. That means it is moving to the right. The direction of the train is moving to the right. But for here, the gradient is 0. So velocity is 0. Here velocity is positive. And over here, the velocity also, the gradient also positive. Okay, means it's moving to the right. Velocity positive means it's moving to the right. Okay, so for first stage, okay, again, look at the first stage. Maybe I draw first. Okay, for the first stage, it is moving to the right until 4 meter. Until 4 meter. So the train, it moves to here. Okay, 4 meter. It moves up to maybe until here. Yeah. Okay. It moves up to 4 meter. Yeah. Positive 4. Positive 4 meter means at the right hand side of the origin. So the velocity, what I can say is, yeah, the velocity is positive, means moving to the right. Moving to the right at constant velocity. So, right. This is for the first stage. Okay, this is for the first stage, and then for the so maybe I can write it out. Yeah. So for the first stage, okay, maybe I should make it bigger. Yep. Yeah. For the first stage, the train is moving to the right. To the right. I need to find out the velocity also. Yeah. I need to find out velocity. Okay, let's find out the velocity. I cannot just say moving to the right. I need to find out the velocity also. Okay, what's the velocity? Maybe for we put this as v1. Okay, this is v1, v2, v3. We know the v2 is stopped temporarily at 4 meter, and then v3 is moved again to the right. Okay. So v1, we need to find out v1. So this is the v1. Okay. So what's the value of v1? Yeah. Maybe we just drag this a little bit down here. Okay, let's find out v1. So v1 is equal to the gradient of the graph, the gradient of this part. Yeah. ds dt, which is 4, it is 4 minus 0 over 6 minus 0. So what do you get for this answer? Okay, I got 0.667 meter per second. That's for v1. Right. Next is okay, so we can say train is moving to the right at v1. Yeah, v1 equal to 0.667 meter per second. Yeah, moving to right at this speed until s equal to 4 meter. Okay, moving until 4 meter. And then after that, number 2, what happened at the stage 2? It stopped temporarily. Yeah, displacement graph shows the gradient 0. Gradient 0 means velocity 0. It stopped temporarily at 4 meter. Okay, the train stops temporarily at s equal to 4 meter. Yeah, at position s equal to 4 meter. It stopped temporarily over there. Okay, and then v is 0 meter per second. Okay, the velocity at that time, the second velocity at that time is 0 meter per second. Okay, then finally, third. So I can write here velocity is 0. Yeah, velocity is 0. This is for number 2. Yeah, this is for the second part. So for the third part, it moving again. It moving again to position 10. Oh, this is in centimeter. Oh, this is in centimeter. So be careful. Be careful with the unit. So this is not meter. I'm wrong all this while. This is all in centimeter. You see that? That's very you need to be careful. Yeah, this is all in centimeter per second. So I'm wrong over here. This should be centimeter. Yeah, centimeter. Sorry. Yeah, centimeter. So, and then for the third part, it's moving to the right again because the gradient is positive, the velocity is positive. It's moving to the right again. At what velocity? We need to find out what's the velocity over here. Okay, this is the third part. This is the third part. Okay, so let's find out the velocity. Okay, let's find out the velocity. Velocity 3 is the gradient again at that point. The gradient of this one. So it is 10 minus 4. 10 minus 4 divided by 14 over minus 10. Yeah? 14 minus 10. 14 minus 10. So what's the answer? Let's find out. Okay, so I got the answer is 1.5 centimeter per second. Okay, so this is a positive value. Positive velocity means it's still moving to the right. Okay, but now it is traveling at much higher speed, faster speed. Yeah, the V3 is much faster. So I can say from here is the train is moving to the right at V3 at velocity 3 1.5 meter centimeter per second until position. Just now I should write a position here. Yeah, position. Yeah, this one also position. S equal to 10 centimeter. Yeah, that's correct. Okay. It moves at this speed. Yeah. So we can say if we compare the gradient, you see, we compare the gradient. This one is steeper. The third part is steeper compared to the first part. So that means this one has higher gradient. This one smaller gradient. Higher gradient means higher velocity. This one lower gradient means lower velocity. In fact, you see, with V3 we get a faster velocity compared to V1, lower velocity. Yeah. So this one travel, the first part travels slower. This one travel faster. So what I can say is the gradient of displacement time graph is velocity. Understand? What I can say just briefly is the first part is in moving to the right until position 4 cm at this velocity at the slower speed, and then here 6 to 10 seconds is stop temporarily. Stop temporarily at position 4 cm. Stop temporarily, and then for the third part is moving at higher speed. Moving at higher speed at 1.5 centimeter per second until position 10 cm. Okay, that's the thing. Now sketch the velocity against time graph. You see, centimeter per second. Sketch velocity against time. So I already calculated the value here. Now I want to find the velocity graph. Okay, so let me do it. Yeah. Okay, put it here. Okay, I duplicate the graph over here. Now I'm going to draw a velocity time graph. I need to draw a velocity against time graph. So I need to refer to this graph, okay, to draw. So now I draw it. Okay, velocity. Okay, this is the axis I draw. Okay, now I draw this is the velocity. Okay, now here this is a velocity okay, velocity this centimeter per second. Okay, and this is the time. Okay, so now I need to just relate here like that. Okay, now okay, I already got the value just now, isn't it? I got the value v1. Okay, so here this one is the gradient. Just now I already got here the gradient of this. This is the v1, the gradient of displacement time graph. The gradient of this is just now is 0.667. Positive 0.667. Here v2 the gradient is 0, and then here much higher speed, faster speed is v3. This is a positive 1.5 meter centimeter per second. So I just draw it. Yeah, I just draw the graph. So the first part is here 0.667 straight line. Actually I use line, yeah, to draw. This is the v1 here, v1. Okay, and then here again 0, second part is 0. And then draw another one over here, higher speed. Okay, so what's the value over here? This is the v1, which is positive 0.667 centimeter per second, and then over here this is the v2, 0, yeah, 0, and then here okay, I need to relate to this part. This is the v3. This is the v3 equal to positive 1.5 centimeter per second. This is 0 to 6 seconds, and then this is the 10, and this is the 14. So between 0 to 6, it is 0.67. Between 6 to 10 is stopped temporarily. Yeah, here the velocity graph shows it stopped temporarily because here velocity 0. Yeah, this is v2, 6 to 10, and then 10 to 14 it moving to the right again. Yeah, 1.5 velocity. Okay, this is the graph. So when you sketch you need to label. So understand, you need to show all the value. You cannot just draw the graph without any label. You must label. You must label the value, and also you must have the axis. You must write the axis. Okay, you must have the symbol and the unit. And you must label all the value. Must label both the value both at x and y axis. Must label. Cannot just draw the graph only. Understand? Now, next, determine the average velocity for the whole journey. Okay, the whole journey is C, part C. Average velocity for whole journey. So again, what is mean by average velocity? Average velocity is average velocity is velocity for a certain period of time. It has a certain period. Instantaneous velocity is only for a specific time, but average velocity is the whole journey for a certain period of time. So we need to divide by the total time taken. It's total average velocity is total displacement divided by total time taken. For period, it has a period of time. Okay, so please write here. Please write here. So average velocity, V average, the formula is average velocity is total displacement divided by the total time taken. Total time taken. So the total displacement. So this is a displacement graph. So what's the total displacement? It's already here. You see the total displacement from origin. That means it is the between the initial and final point. That's the displacement. You know which one is the initial point? Here it start from here. This is the initial point, and this is the final point. So displacement is the shortest distance between initial and final point, which is 10 centimeter. This is the total displacement. Okay, so the total displacement is 10 centimeter. 10 centimeter. And then what's the total time taken? Total time taken is 14 seconds. Okay, for the whole journey, because he mentioned sometimes you ask not just the whole journey. Maybe he asked average velocity for between 6 to 14. 6 to 14. So you need to minus lah. 14 minus 6. But this one is the whole journey. So whole journey is the from 0 second up to the final 0 to 14 seconds. So the whole journey, the time taken is 14. So it's 14. Okay, so it's 14. So what's the answer? It is the 0.714 centimeter per second. Get your unit right. It's not meter per second. It's centimeter per second. Okay. Then calculate the instantaneous velocity at 12 seconds. So what's the instantaneous velocity at 12 seconds? That means I want the velocity at which part? I just write off this one. Okay, I want the velocity at here. Velocity at 12 seconds. That means just write off this. I want the velocity at 12 seconds only. This is a specific time. What's the instantaneous velocity again? Instantaneous velocity means velocity at specific time. Specific time at certain time. At let's say velocity at 10 seconds. So this one he said, what's the instantaneous velocity at 12 seconds? That means I want the velocity at 12 seconds here. That means the velocity at this part. Velocity at this part is looking at the gradient of the graph. Still remember? Still remember to find the velocity at specific time is the gradient at certain point of the displacement time graph. Displacement time graph, the gradient at that point. So for at 12 seconds, we need to find the gradient. The gradient over here. The gradient. So the gradient, this one is the velocity at the instantaneous velocity at 12 seconds. The gradient of this graph. So the gradient of this graph is you just find the gradient of this part. This part. This is actually just now we calculated V3, isn't it? This is actually V3, and V3 is actually the what is V3? 1.5 centimeter per second. So we already got the answer. Just copy this one. Just copy this one, this part. Sorry, just copy this part, and that's the answer. That's the answer for question D. Question D, which is this one. So the answer is 1.5 centimeter per second. The gradient for this part. Is it correct? Yes, it is correct. 1.5 centimeter per second. 1.5 centimeter per second. Yes, that's the velocity at that part. So average velocity is velocity for the whole, velocity for the whole journey. Average velocity for the whole journey. That means from this point till this point. Remember, I tell you before, the difference between instantaneous and average. Like you see, this is for this slope, this is the instantaneous. Okay, this is the instantaneous displacement time graph. This is the instantaneous. This is the average velocity. You need to take this point to this point, initial to final point. Okay, initial to final point. This one, delta S divided by delta T. That's the average velocity. Instantaneous velocity is only 1 point. Okay. So just now the average velocity is we are taking the from here up to here. You understand? We're taking up from here up to here. Instantaneous is only at the 12 second only, yeah, the gradient at that point only. Okay, so that's all for this question, yeah. Hope you enjoy, and let's proceed to next video.